we have these kind of different data types available. What is the significance? Why did they make all of these data points? Let's have a small discussion around it here, right? That why all of these data points are needed. So basically what happens is, see, this is my CPU, right? This is the user here, and this is here my GPU machine. Now GPUs have the capability of processing at high speed. CPU
Sharing a
are
different
cheaper machine, cheaper processing units.
Anand, are you drawing something?
Oh, is it not showing?
No,
Yeah,
it's in your code.
yeah. Right. I shared the wrong window, I guess. Right, now we can see. Okay. So here we have user. And this is where we have CPU machines. This is where we have GPU machines, the most costliest asset in 2025, right? GPU. People are spending millions on this. So basically what happens is uh, we create a data type that is easy for us to, manipulate. We can easily edit, delete, and do all sort of things, right? Then I need it to convert into something that will run fast on this CPU or run fast on this GPU. Unfortunately, Python is most inefficient language to run on CPUs and GPUs. For user, it is the best. It is plain English, basically. If you see, it is nothing much. It is plain English, right? The most user-friendly language, but it is slow, not best for it. So what they have done is they made small functions so that it can be converted into C++ code automatically. I mean, C++ coding is tough. So what they did is they made small functions so that it can be converted internally into C++ code, and GPU and CPU can easily use it. So all of this. Now, if you see, this was a small mistake I was also doing here. Although I did not wanted to do it, but I had to do it. So basically, I had to convert this data into my NumPy. NumPy is basically nothing. It is still array, but it is not so human readable, but it is optimized for NumPy is a library that optimizes speed of data for CPU and GPU. That's it. So I'm doing this only, right? And once I have done, next part is basically I want this function here. I have to tell that what is the input that I'm giving to my model. The input is, what is the shape of the input? Shape of the input, this was the first question that was asked by basically Cure, that if these are neurons, right? We need to declare that how many inputs are we giving to this model? How many inputs are we giving, right? Forget about the function name. Function name will change in many of the libraries, but the whole point being that we call it input size. right? And then we also need is output size, although we know whatever we have target, that will be our output size, right? This target. So this is what I'm doing. That I have specified that I have taken 8 size input. Is it really the case, right? So my data that was here x train df, so it is 1 2 3 4 5 6 7 and 8. This is my input data, 8 here. I can give any name to it, whatever name I want to give, right? I just have to give it input size, declaring the input. All of other things, but I also need to tell it the output. The previous program that I was trying, even this was automatically detected. I did not wanted to make it over complex, although we have to do it. Next, we need to declare out our output. Basically, we'll have to declare our output. Now, just wait for this program for output. What it is saying, I'll come to that. Basically, these are various ways I want my model to try it, and then so these are small error functions. These measure how basically we want our input to be mapped to output. So in short, if you see, we have input, we have output. This is, we have input, we have some input, and then we have some output. Now I can decide that it went through model, right? And it said that original output is this, I call it O1, but it predicted O2. It predicted O2, right? Now I want that this delta, that is O2 minus O1, that is whatever the difference between both of them is there, it should travel back to my model, where it is going to adjust the weight. This is the whole life cycle. This is, we are going to talk it again and again, because there are so many ways of doing just this process. Here we will see that what are the different kinds of ways we can calculate this error. This is called as error, right? There are various ways. I mean, we'll be calculating this error, and our whole cycle is to minimize this. This is complete whole AI. To minimize this is our struggle that we'll be going. The minimum this is, the better our model will be. The better mapping has been done, right? The better we have mapped it. So as of now, you can copy paste it. Why we have chosen it, there is a small list that I will give you. Basically, this is how we start, and starting as we go further, we can remember it. Ideally, the name says mean squared error. That is, whatever the error is there, you find the mean and you square it down. I mean, mean means you find the mean, that is, add it and divide by 2 and square it down. And mean absolute error, no squared error. You just need the mean and you're not squaring it off. All this is this dead simple, right? We have been doing all of these functions in Excel in decades. All of this, right? And I have given name, right? But I will need separate time to explain all of this. Anyways, right? And next is, this is automation function. What it does is auto model. Earlier I was using different function. It will automatically go search for best model. we have given all of the job to AutoML, right? How many trials you want to? For this, I want to keep 3. You can go for 10, 20, 50, whatsoever compute you have. It will automatically go to every model. It will check with your data and it will evaluate that and it will come up with the best model. It will automatically choose the best model, right? We do this, done. And next, we set it go. We say that, okay, start running and just run around. I want epochs is basically how many rounds of training, will happen, right? If you understand it here, it goes here and it comes here, round number 1. So similarly, this whole cycle, how many times it is going to process, how many times it is going to calculate error and update it. So this is all we'll have to understand, right? As I say, reg.fit, you see it has started running trial 1. What it is doing, it is doing running trial 1. Okay, trial 1 is completed. These are the values. Trial 2 is also complete, and this is trial 3. Trial 3 is completed, right? Which one is the best model? We'll have to just use an evaluate function, right, to see that which model has basically performed the best model. For that, I can you see, guys, total parameters was basically small amount of, this is a very small model. Input layer is 8. Then you have another 8 layers. And then you have dropout, you have regression output of 1 layer. So a small, very small model has been chosen, 36 parameters only, 36 parameters. This is extremely small model which it has taken. Now what you can try to do is you can just go and change this parameter, that is max trials. You can try with 10, 20, or you can choose any other data, right? And you can give to this model and you can try that how it is performing. But as of now, if you want to see that how is it performing, let's go for an evaluation function. Okay, so here ideally it is not giving you that how much % accuracy it has, but it is giving you what is the loss that has occurred, what is the mean squared error it has occurred. So basically here it says that mean absolute error is 0.67%. That is, it has 30% deviation. That is, let's check that what it says for any of x underscore test underscore df. This was my testing data on which it has not been trained, right? I'll take for first 3 data and I'll feed it and I'll see how it performs. So there is a predict function here which we can use. I'm not going for all of them. Okay, sorry, it does not take df. I'll have to go this route only, x underscore test underscore np. Okay, so here I have all of the predictions. This is 0 Earth 1 2, and then I need to check my real data also, x underscore test underscore. So it is not at all matching. This time it is not matching. The first data, it says -11 and y test. This is not even close. Predictions are actually very bad. So ideally we should go ahead and train more. We can go ahead and train for 100 epochs ideally. And because this is a very bad output. When I was practicing in the morning, basically I was using a different class altogether. And instead of auto model, I was using instead of this, I was basically using another class called as this is also using so here my output was quite close. Prediction for new sample was this was actual value 0.47, 0.477, 1.03. Here this one was different, but here it was 3 and 5. But this output is very bad actually. So what we can try to do is ideally we will have to keep on trying with the best till it does not arrive with the best parameter. Also, we'll have to try to increase this parameter. Instead of 3, we can do it for like, here it is, input, and yeah. Instead of 3, we can at least try with 10. This is one thing that we can change. However, there is one more point that we need to take care. The point being that usually for demonstration purpose, this is what we have done is to run our first model. Irrespective of the fact what it will give, we have to run our first model, right? This is the whole point. So what we wanted to practice is we have an input and then we are training the model irrespective of the fact it is trained good or bad. I just want you to play with the model and we get an output, right? And we repeat this whole cycle again, right? For simplicity, what I have done, whatever the input I get, I have fed it into the model. Now, ideally, what happens is that, see, these are math machines. That is, these are like calculators, right? Now, just imagine that calculator, when it takes some input from you, it goes into, whenever it is converting data into some other format. So for simplicity, what happens? Let's say you have different parameters. That is, you have house, uh, number of rooms. Sorry, you have number of rooms, right? And then you have area, you have latitude, you have longitude, right? And so on. Now, area might be, let's say, 2000 square feet or something, whatever the unit they have taken. Number of rooms might be 4. Latitude can be 1112 or something like that. Minus, it can be in minus also. Ideally, what we do is we normalize the data. But this we will discuss later on. Normalizing data, we'll have to do certain visualization. The whole point being the same theory, that we'll have to bring the data to some mean point. Extreme is also not good. Extreme of high as well as extreme of low is not good. So we'll have to bring the data on a scale so that all of these values, so that this -2 and 2000 and -12 make some sense, right? All of this should make some sense. So hence, we are not getting here very good results. But next, what I can do is I can share a cleaned notebook with all of you. I'll share it in the group. Both of these notebooks I'll share in the group. I'll clean this notebook, and then you can run it. At least try to run it once. At least try to go click, click, click and run, right? And try to change these parameters and see what happens, right? I'll add the comments also so that you understand what it is, right? I'll add the proper comments. And next time when we meet, if anyone is not able to run this notebook, they can tell me and we can run it together, right? Although this is a very small one. And then as we go further, we'll work on how to improve these kind of outputs. Basically, all of this error that we got, it was not good. So we'll see how we can actually do better predictions. So the whole point here being the accurate predictions and better predictions. Fine, team, because we have already exceeded half an hour from what we decided.
Thank you, Anand. It's definitely very interesting, actually.
Thank you so much. And there is more to come in future, right? This was the first program. Now I want everyone to learn to at least execute it. And the main point being, see, again, I'm saying code is not the main point here. The main point is your investigative mind. You'll have to connect all of these things that, okay, this is the number, I need to check this, I need to check this, and then we can get the best prediction. So it is like an astrologer's job, right? All right, team. Okay. Thank you for attending, and I'll post the tentative timings. I'll post a sheet so at least you can all put maybe Wednesday or Thursday, whenever you feel, whichever day you feel. So we'll keep it in the evening so that everyone can attend, right? And yeah, that's it, I guess.
Sure. Thank you, Anand. Bye-bye.
Thanks.
All right.
Thank
Thanks.
you.
Bye.
All.
Thank you.